Hello and welcome to this video channel. I'm DC. In this video, I'm going to show you how to use Atmel AT88SC102 secure memory cards. So I'll be covering the following things in this video series. So first of all, we are going to understand the memory structure of AT88SC102 card. And we're also going to understand the datasheet like we did with various other NFC or smart tags. We're going to understand the datasheet, and you're going to see the hands-on with this memory card. We're going to see how to do the various read and write operations, and how to authenticate with the password, and also how to prevent unauthorized read and write access, plus various other features which are explained in the datasheet. You're going to understand how to use the AT88U and the AT128SC102 reader writer commands, which are specific to AT88SC102 memory tag. So this is a very nice to know type of a tag. I'm not very sure where these tags are used these days. However, the way the data is organized and the buzzwords like the fuse, the blow, so all these things are very good for the freshers or the young graduates. So as we did with various other tags, the first thing you have to do is get the data sheets. They are easily available either from the sellers from where you buy these tags, or you can download from the manufacturer website. So this is the overview of AT88SC102 memory cards. So these are categorized as a secure memory cards. If you compare this with my other videos on AT24SC16 memory cards, these are also called as I2C memory cards. So we have seen there is literally no security with these tags. The entire memory is available for both read and write operation, and you cannot lock or password protect any section of the memory. But we also have other secure memory cards like SLE4442 or SLE4428. These cards, even though they have a very simple memory structure, they do provide us with the locking from read, also locking from write operations, and also the password protection. Now, since I have not used this type of memory cards before, I could not comment anything more about the applications. So if you read the documentation of this card, it mentions that these cards are used for the loyalty cards and the prepaid cards, but I myself have not seen any cards Now I'm going to use the following readers. I'm going to use the ACR38U. This is from the company called ACS. I've used this reader writer along with the SLE4442, and these reader writers are quite reasonably priced. And I'm also going to show you how to use with the ACR. I think it's 1281, sorry, 1281, not 2181. So now this is a dual interface reader writer where it supports both contactless and contact. And bear in mind, these memory cards are contact cards. There is also one more reader writer from OmniKey, that's OmniKey 3121, but this uses a very a proprietary DLL called Synchronous API. I'll not be covering the OmniKey 3121. I've seen using this ACR reader writer. It's pretty easy to access AT88SC102 cards. These are some of the features put in my own words. Again, if you see the documentation, there's a very nice explanation about these features in depth. Now the memory is organized into various sections. Now this is something which you don't find with the other non-secure memory cards of from Atmel. Now you can password protect both read and write operations. Now this card has got a auto locking feature, where upon successive wrong password the card gets permanently locked from any further authentication. Now when you buy a brand new tag, the entire memory is filled with the logic bit 1. So it's quite possible that the card can also come with some bits which is not 1, but I'm going to explain about that in my future videos. This supports the write and erase operations. So we have seen these write operations many times in my early videos. Now there is a difference between the write and erase operations, and this is very crucial in understanding this tag. A write operation means it's always changing from bit 1 to 0. If the memory bit is already 0, you cannot change that to 1 using the write operations. Whereas an erase operation is changing from 0 to 1. Now here these two operations are very crucial, because as you can see here, the default memory, a brand new tag, is filled with all logic 0. So in order to erase, or in order to erase some section of the memory, you must have a privileged access rights, like a super user type of access rights, to change from something written back to the factor setting 1. Now it supports a concept like a manufacturer issuer model. So this is a very interesting model, and what it means is, when the card is manufactured, so probably now just explain that with a simple block diagram. So you got the manufacturer, and assume that I'm the issuer, so I'm interested in using this memory cards, and this is my end user. Now when I order something with the manufacturer, say a pack of say 10,000 cards, the manufacturer, during the manufacturing or fabrication process, they're going to enter or have my customer ID in every card. And also all these cards, they come with a predefined password which only I or the issuer know about it. So think about that. In this model, if these cards are stolen or if it is lost, so unless somebody knows my password, they cannot use these cards. So that is called as the safety during the transit, and the password is also called as the transport password. These are some of the interesting buzzwords I mentioned before. It's good to know, especially for fresh software developers. It's interesting to know all these type of concepts. And once I get this this memory card, so I can change the password, and I can personalize it, and I can pass on to my users. Now when the users get this tag, we can say that the tag is running at the security level 2, which is much stricter than the card valid security level 1. So we're going to know all these buzzwords, okay, will be very clear in my later part of videos. So the first thing you're going to do is get the documentation. So these are the two documents you need to get from internet, and the one is the information about this AT88SC102 memory card itself, And you can probably, you'll come across a older version of the document. Now I'll be using this new version. Probably you can make out from this blue label Atmel logo. And the other one is, because I'll be using the AT88SC102, you have to get the the documentation from the ACR website as well. You can see here I've connected my ACR38U reader writer, and this is the software we have been using for so many videos on memory cards and smart cards, and the support for AT88SC102 is available in version 1.8. So as I keep saying, if you don't have this software, not to worry, there's a lot of things you can learn from these videos. So I'm going to insert a brand new this memory card, and you might notice in general, with ACR38U, whenever you insert a card, it takes quite a while before the reader is ready for any read and write operations. So if you see this a continuous flashing light, please wait until the flashing light dies. So now it looks like it's all right. You can see here, the first thing is identify all the readers connected here. Somehow nothing has been recognized. Now once you get the reader, you can see I've got ACS CCID USB reader 0. I'm going to click on connect. Now based on the ATR, the software automatically opens this screen, and this is a new screen. This is still under development. Probably this screen is going to evolve during this video sessions. So because I'm using ACR38U reader writer, there is a very standard way of accessing any memory cards. The first thing we do is select the card. Now this screen is a little bit different from the other screens. The commands are now shown at the bottom of the screen, and you can see here these are the standard APDU. For every command we send, the 9000 always means a success. You hardly get any error responses using these type of memory cards, so we'll come to know that soon. So the first thing is we need to bring the entire memory content into the software. And probably I forgot to mention that this AT88SC102 comes with 1 kilobits of user memory. It does have additional memory. They're not meant for the user data. They're meant for like protection and password and access rights and so on and so forth. Now if you look at the documentation here, now this is the structure of this memory. It's a very clear explanation about how this memory is organized, and information about what each of these sections does. And I'm going to speak about this as and when the video progresses. Now at present, to summarize, what you see here is, for every section of the memory, you see the bit address. So keep in mind, we are speaking in the bit addressing, not the byte addressing. It's a bit addressing. So the first 16 bits is used for, or is called the fabrication zone. At the bottom of the document, this explanation about what exactly the fabrication zone, and the code FZ, keep in mind these 2-letter abbreviations are used everywhere in the documentation. And here you can see the number of bits for each of these sections, and also in words. A word in this Atmel documentation, a word means 16 bits. Take one more example. The next section of the memory with the bit address 16 to 79 is called issuer zone, IZ, and this has got 64 bits of memory, and which is equivalent to 4 words. So like that, you got so many things to learn in this documentation. So I'm going to go in a very slow motion. Probably I'm going to take you in a path where it's easy for all of us, including myself, to understand this memory. So the first thing is I'm going to hit this. So as you can see here, there's one single command which reads the entire memory. So if you convert all the bits to bytes, you will probably have 196 bytes, I suppose. 196 bytes is same as reading the entire the memory content. And here you can see that this follows exactly the documentation. We have a fabrication zone, and I'm showing here the value in hex. But if you're interested, in fact, you for some application or some concept to understand, it will be easier to know if you see the data in the bit. So if you tick here, this shows the bits. And what we have to keep in mind here is the bits here. It says 001111. So this is the lower bit and this is the higher bit. But when you convert this into a hex number, now the way we write hex number is the first is the higher nibble and the lower nibble, F0. So just try to keep this in mind when you understand this software and the documentation. So the next is, so for each section of the memory, so I have made a separate tab here just to understand, to make it simple to understand. And some tabs shows multiple sections. For example, this tab are called FZ and IZ. FZ is a fabrication zone, IZ is a issuer zone. It's all in single tab. And there are only few operations you can do on a memory. Either you can read or write or erase. So these are the only three operations. So the next is you got issuer zone. Now this is the raw data. So if you remember, I mentioned before, a brand new tag comes with the memory which is all set to the logic bits 1. Now everything here you can see is set to logic bits 1 except the very first zone called the fabrication zone, which the documentation says this is something the manufacturer writes about what version or probably what date is manufactured and so on and so forth. The fabrication zone is a read-only. We cannot modify or erase. However, I do have the erase and write. See, for each section here I got erase and write. For issuer zone I got erase and write, and also what word to erase. So next is the security zone. So let's speak about the issuer zone. An overview. The issuer zone is for issuer of the card. If I am buying say 10,000 cards, if I can put my customer IDs in the issuer zone. This is something I personalize my tag. Next, security code. This is something like a password. The password is stored here. And the next is called the security code attempts counter. If you remember, I mentioned that this tag has got a feature where the card tracks how many wrong password has been entered. In this memory, even though you can see the 16 bits, doesn't mean you got 16 attempts before the 16 wrong password attempt. No, it's only the 4 attempts. After the 4th wrong attempt, the card gets automatically locked. Now next zone is called code protected zone. Now this is again a 64 bits, and in order to read and write you need to first authenticate. And the next is called application zone. This is where the user data is kept, the application area. So you got 2 application areas, application 1, application 2, and each of these areas, I suppose there are 64 bytes each. Now you can put whatever we want. Again, the application zone can be protected by password. You can read protect, write protect, and both read and write protect. Next zone is called application zone error, erase key. In order to erase, so bear in mind, erase means changing from 0 to 1, and write means changing from 1 to 0. So if you know if the memory is already if the memory bit is already 0, you cannot, if you try to write a 1, the memory does not change to 1 at all. So write is always change from 1 bit to 0 bit, where erase means you can change anything 0 back to 1. Now this is like a password to erase application zone 1. Now if I authenticate with this password, we will be able to erase the zone 1 as well. Next you got application zone 2. This is again a application area. Now if you consider these two, you can think this as a two application card. So I can have one application, say for example for a library access, and the second application I can have it for like a canteen access. So this is a multi-application card. Now because this is a separate zone 2, there is a separate erase key for zone 2. So in order to erase zone 2, you have to authenticate with this erase key. So you got the first key, this security code. This is like a super user key. Then you got a erase key for zone 1, erase key for zone 2, and also you got something called application zone 2 erase counter. Now this is an interesting feature here. Zone 1 I can erase unlimited number of times. Now the documentation says you can do 100,000 writes to this tag. So there's no limit on number of times you write to erase zone 1, whereas using this feature of controlling how many times zone 2 can be erased, the maximum is 128 times. So you have a control on how many times zone 2 can be erased. This section is called the memory test zone. So you can always, anytime, without any password, you can always read and write. This is like a playground for the developers. So you can write, erase, read without any password protection. Even though the card is permanently locked from access, you can still read and write to this zone, erase to this zone. The next is called as a manufacturer zone. So probably this section of the memory can be used by the manufacturer to store the customer ID, and this can be locked forever. This is called the block write erase section. Using this I can erase more than one section. Erase more than one section. Erase means setting everything to 1, but here if I do block write, I can clear more than one section to 0. If I use block erase, I can fill more than one section with ones. So that's what it means. You're going to see that hands-on later. These are the 3 fuses, like the manufacturer fuse. So even though you can see 16 bits here, but there is only one single bit used here. Now blowing this fuse means new tag will always have the bits as 1. If I set this to 0, that indicates it's a blown state. When the manufacturer fuse is blown, certain sections are not available for writing or erasing. You can just make certain sections read only. Likewise, you got the issuer fuse. So if this fuse is blown, so you cannot modify the issuer zone. And also there's a transition from if you remember, I mentioned a little bit about the security level 1 and security level 2. When you blow the issuer fuse, you're bringing the card to the security level 2, which most operations will become very strict. And before blowing issue fuse, the card operates at security level 1, which you can do erase most of this area. So not to worry, you'll know more about that in the later videos. This EC2 infuse, if you remember, when we spoke about the application zone to error counter, now this is a feature controls how many times you can erase the zone to. Now this feature can be enabled or disabled by means of this fuse. So I think we have covered most of the theoretical aspect here. Now just to keep this going, okay, make it very interesting. So I'm going to show you how to write to the memory test zone. As soon as you click here, the software makes the corresponding tab active, and this is the default value. I'm going to write this as A B B. Say write. Now the write is successful. This is the command. Now this is the command which the same command works even for SLE memory cards. Now 900 is a success. In order to see that the write is successful, at present you still have to go and click the read entire tag. You can see that the memory has been changed. Now I'm going to erase. Okay, so when you hit this erase, now there's a different command here. Now the 38U documentation explains. So to be honest, okay, these ACR38U made this using this tag so simple. Just send few basic commands, you get so many things happening there. If you click on read entire tag, that erase back to all the bits are back to FFs. Okay, that's all in this video. So thanks for watching. You got so many things to cover. Probably this playlist on AT88SC102 will be pretty long. So looking forward for you in the next videos. Thank you.